December 9, 1941. Pearl Harbor Navy Yard, Hawaii. Captain Homer Wallin stood at the edge of Drydock Number One, staring at a problem that should have ended the Pacific War before it started. 8 battleships sunk or damaged, 3 destroyers blown apart, cruisers torpedoed, burning, listing. The Japanese had calculated that repairing this devastation would take years. They were wrong. Wallin looked at the capsized hull of USS Oklahoma and did the math that would terrify Tokyo. Not how long to repair, but how fast. This is the story of how American industry accomplished something the enemy thought impossible. They repaired a fleet faster than it could be destroyed, and in doing so they revealed the fatal flaw in Japan's war strategy. The morning of December 7, 1941, had seemed impossible to survive. 183 Japanese aircraft in the first wave, 171 in the second. Torpedoes specifically designed for Pearl Harbor's shallow 40-foot depth. Armor-piercing bombs converted from 16-inch naval shells. The attack lasted 110 minutes. When the smoke cleared, the devastation was total. USS Arizona had exploded when a bomb detonated her forward magazine. 1,177 men died in seconds. The ship settled to the harbor bottom, a funeral pyre that would burn for days. USS Oklahoma took 5 torpedo hits in rapid succession. She capsized in 12 minutes. 429 men were trapped inside her overturned hull. Rescue crews could hear them pounding on the steel. For days. USS West Virginia absorbed 6 torpedoes and 2 bomb hits. She settled upright on the harbor bottom, her decks awash. 106 men dead. But she was sitting level because her damage control officer, Lieutenant Claude Ricketts, had counter-flooded compartments to prevent capsizing. Even while dying, he'd saved his ship. USS California took 2 torpedoes and settled slowly into the mud. USS Nevada, the only battleship to get underway during the attack, took a torpedo and 6 bombs. She beached herself to avoid blocking the channel. USS Tennessee and USS Maryland, moored inboard of other ships, escaped torpedoes but took bomb damage. USS Pennsylvania sat in dry dock during the attack and suffered moderate damage. 3 destroyers were wrecked, 3 cruisers were hit, 188 aircraft were destroyed, 2,403 Americans were dead. Japanese planners had calculated their victory carefully. America's Pacific battleship fleet was eliminated. The nearest reinforcements were thousands of miles away on the east coast. Repairs to Pearl Harbor's facilities would take years. Japan had bought itself 18 months to consolidate control of the Pacific. Time to fortify island positions. Time to extract resources from conquered territories. Time to build the Greater East Asia co-prosperity sphere. But Japanese intelligence had made 3 critical errors. First, they'd failed to destroy Pearl Harbor's fuel storage tanks. 4.5 million barrels of oil sat in above-ground tanks. 1 bomb could have ignited an inferno. The Japanese left them untouched. Second, they'd left the submarine base intact. America's submarine fleet would become Japan's nightmare, but on December 7th, they sailed away unharmed. Third, and most fatally, they'd underestimated American industrial capacity, not just to build new ships, but to repair damaged ones. Captain Homer Wallin understood this immediately. Wallin was 50 years old on December 7th, born in North Dakota, about as far from the ocean as possible in America. But he'd spent 30 years preparing for this moment. Naval Academy, class of 1917, served on battleships during World War I, joined the Navy's Construction Corps in 1918, master's degree in naval architecture from MIT in 1921, 20 years working in Navy yards across America. Wallin knew ships. He knew how they were built. More importantly, he knew how they broke. On January 9, 1942, Wallin took command of the newly created Salvage Division at Pearl Harbor Navy Yard. His orders were simple: assess the damage, determine what could be saved, save it. Wallin began with triage. Category 1, ships that could steam to the mainland for repair. USS Pennsylvania, USS Maryland, USS Tennessee had escaped major damage. USS Pennsylvania left Pearl Harbor on December 12th, just 5 days after the attack. USS Tennessee followed on December 20th. USS Maryland departed December 30th. These ships would receive repairs at West Coast Navy yards. New guns, updated fire control systems, improved anti-aircraft defences. All three would return to action in 1942. Category 2, ships that needed significant work before they could move. USS Honolulu, USS Helena, USS Raleigh fell into this category. Pearl Harbor Navy Yard worked around the clock. Temporary patches sealed torpedo holes. Pumps removed thousands of tons of seawater. Damaged compartments were shored up. USS Honolulu was ready to sail by January 1942. USS Raleigh by February. USS Helena by June. Category 3, ships that were underwater. This was Wallin's real challenge. USS Nevada, USS California, USS West Virginia, all sitting on the harbour bottom. USS Oklahoma capsized with her bottom pointing skyward. Traditional salvage wisdom said these ships were lost, too damaged, too expensive to raise, too time-consuming to repair. Wallin disagreed. He assembled a team that would rewrite salvage engineering. Divers from the Navy's Construction Corps, engineers from Mare Island Navy Yard, welders recruited from West Coast shipyards, machinists from civilian industry. Many had never worked on a salvage operation before. That didn't matter. Wallin needed people who could solve problems no textbook had answers for. The first challenge was understanding the damage. Divers descended into the oil-fouled water. Visibility was zero. They worked by touch, mapping torpedo holes, bomb craters, and structural damage. Each dive lasted 20 minutes. The cold water and heavy equipment limited endurance. Divers surfaced, reported their findings, and the next team descended. Day after day, week after week. They discovered that USS West Virginia had taken 6 torpedo hits. Each had blown a hole 20 to 30 feet in diameter. Her port side looked like Swiss cheese. USS California had taken 2 torpedo hits and settled onto the harbour bottom at a slight angle. Her machinery spaces were completely flooded. USS Nevada had beached herself deliberately. She was half in the water, half on the beach. Salvaging her would be easier than the others. USS Oklahoma was the nightmare scenario. She'd rolled completely over. Her bottom now faced skyward. 429 men were trapped inside. Rescue crews cut through the hull with acetylene torches. They worked against time. Air wouldn't last forever in the sealed compartments. For the first 3 days, they heard tapping, Morse code messages from survivors, frantic pounding on bulkheads. They cut faster. 32 men were pulled alive from USS Oklahoma. The last survivor emerged on December 10th, 3 days after the attack. The others, 397 men, would remain entombed, but Oklahoma herself might be salvaged, if they could right her, if they could pump her out, if they could repair enough damage to make her seaworthy. It was a monumental if. Wallin started with the easier ships. USS Nevada first. Nevada sat partially beached near Hospital Point. Her bow was on the beach, her stern in deeper water. The plan was straightforward in concept. Seal the major holes, pump out the water, refloat her. But execution was brutal. The torpedo hit on Nevada had blown a hole in her port side, approximately 40 feet long, 20 feet high. The edges were jagged, twisted metal. Navy yard workers fabricated a massive wooden and steel patch. It had to fit the exact curvature of the hull. It had to seal against thousands of tons of water pressure. It had to be installed underwater. Divers guided the patch into position. A barge-mounted crane lowered it carefully. The patch weighed several tons. Once positioned, divers drove bolts through the patch into the hull. Each bolt had to be tightened underwater, in zero visibility, with tools that weighed 20 pounds. The work took weeks. While exterior patches were installed, work inside continued. Every hatch was sealed. Every porthole closed. Every opening that could leak was plugged. Then came the pumps. Pearl Harbor Navy Yard had several types of pumps available. Standard fire pumps could move 500 gallons per minute. Larger industrial pumps could move 2,000 gallons per minute. But removing water from Nevada required innovation. Engineers installed deep well pumps. These were vertical centrifugal pumps with shafts extending from topside to the bottom of flooding compartments. A 10-inch pump could move 4,000 gallons per minute. Wallin installed dozens of them. The calculation was simple, but daunting. Nevada contained millions of gallons of seawater. Pumping would take days, maybe weeks, and while pumps removed water, more leaked in through imperfect seals. The pumps had to outpace the leaks. On February 12, 1942, the pumping began. Gasoline generators roared. Pumps screamed. Water poured from discharge hoses into the harbour. Slowly, the water level inside Nevada dropped. As it did, the ship grew lighter. Her buoyancy increased. After 3 days of continuous pumping, Nevada lifted off the bottom. Tugs pulled her into deeper water. She floated. But the celebration was brief. Nevada couldn't move under her own power. Her engines were destroyed. Her turbines flooded with seawater and oil. Her electrical systems completely dead. She needed months of work. Nevada entered Drydock Number One on February 18th. Workers swarmed over her. Damaged plating was cut away. New steel was welded in place. Machinery was disassembled, cleaned, and reassembled. But even temporary repairs took time. Nevada couldn't stay at Pearl Harbor. The yard needed the dry dock for other ships. In April 1942, Nevada departed Pearl Harbor under tow. Destination: Puget Sound Navy Yard. The real work would happen there. The process for USS California was similar but more complex. California had settled onto the bottom, completely submerged. Only her superstructure remained above water. Sealing her was harder than Nevada. More holes, more flooding, more complexity. But the team was learning. Each ship provided lessons for the next. Patches were improved. Divers developed better techniques. Pump placement became more strategic. California was refloated on March 24, 1942. She entered dry dock, received temporary repairs, and left for Puget Sound in October 1942. USS West Virginia was the biggest challenge. 6 torpedo hits, massive flooding, structural damage throughout her portside, but Wallin had developed his methods. He knew what worked. West Virginia's salvage began in January 1942. It took 4 months. On May 17, 1942, she lifted off the bottom. But when she entered dry dock, the extent of damage became clear. The torpedo hits had destroyed more than just her hull plating. They'd blown away sections of her armor belt, shattered internal bulkheads, twisted structural beams. This wasn't repair. This was reconstruction. Navy yard workers fabricated new armor plates. Each plate weighed several tons. Each had to be precisely shaped. Each had to be welded with absolute perfection. The work took 3 months in Pearl Harbor. Then West Virginia sailed to Puget Sound for permanent repairs. Those repairs would take over a year. But she would return to service, and she would have her revenge. He looked at the strategic situation. America's industrial capacity could build new battleships, but it would take 3 to 4 years per ship. Repairing these damaged vessels would take 18 months, maybe 2 years. The math was simple. Every battleship returned to service was a battleship Japan didn't have to face 18 months earlier than expected. Wallin started with USS Nevada. Nevada had beached herself to avoid sinking in the channel. She sat in shallow water with her bow on the beach. Salvage crews began work immediately. First challenge: seal the holes. Nevada had taken 6 bomb hits and 1 torpedo, gaping wounds in her hull. Navy yard workers fabricated wooden and steel patches. Divers descended in heavy canvas suits with brass helmets. Visibility in the oil-fouled water was 0. They worked by touch alone. Each patch had to be carefully shaped to the hull's curvature, positioned precisely over the hole, secured with dozens of bolts driven into the hull. It took 2 months. On February 12, 1942, pumps began removing water from Nevada's hull. As the water level dropped, the ship's buoyancy increased. She lifted off the bottom. Tugs pulled her into deeper water. Nevada floated. But she couldn't move under her own power. Her engines were flooded, her electrical systems destroyed, her ammunition magazines contaminated with seawater. Temporary repairs continued for another month. On April 22, 1942, Nevada left Pearl Harbor under tow. Destination: Puget Sound Navy Yard in Washington State. The journey took weeks. When Nevada arrived, yard workers stripped her down to bare metal. They rebuilt her engines, rewired her electrical systems, replaced damaged guns, installed new radar and fire control equipment. USS Nevada returned to service in October 1942, 10 months after the attack. She would bombard Japanese positions at Attu in the Aleutians. She would support the D-Day landings at Normandy. She would return to the Pacific for Iwo Jima and Okinawa. The battleship the Japanese thought they'd destroyed would serve for 3 more years of war. But Nevada was the easy one. USS California and USS West Virginia were completely submerged, sitting on the harbor bottom in 40 feet of water, filled with seawater, oil, and debris. Wallin developed a systematic approach. First, remove anything that increased weight: ammunition, fuel oil, equipment. Everything that could be unbolted was taken off. Second, seal as many openings as possible while the ship was still underwater. Portholes, hatches, damaged sections. Divers worked for months closing every gap they could reach. Third, install pumps. Lots of pumps. This was the innovation that made everything possible. Wallin didn't try to seal every hole. That would take forever. Instead, he installed enough pumps to remove water faster than it leaked back in. If water flowed in at 500 gallons per minute through battle damage, Wallin installed pumps that removed 1,000 gallons per minute. The pumps ran continuously, day and night, for weeks. Slowly, the water level inside the ships dropped. As it did, the ships became more buoyant. They began to rise. USS California was refloated on March 24, 1942. USS West Virginia on May 17, 1942. Both ships looked like disasters. Oil coated every surface. Seawater had corroded everything metal. Their interiors were a nightmare of twisted pipes, shattered equipment, and accumulated debris. But they floated. And in June 1942, both ships entered Drydock Number One at Pearl Harbor. The work that followed was extraordinary. Engineers cut away entire sections of damaged hull. They fabricated replacement plates of armor steel. Each plate weighed tons. Each had to be precisely shaped, positioned, and welded into place. The damage to USS West Virginia was catastrophic. 6 torpedo hits had torn open her port side. 24-foot holes gaped in her hull. Her armour belt, the thick protective steel along her waterline, had been blown inward. Navy yard workers removed damaged armour plates. Each plate was over a foot thick. Each weighed more than a small car. Replacement plates were fabricated at the yard's steel shops, transported by rail to the dry dock, lifted into position by massive cranes. Welders worked in 3 shifts around the clock. The work was dangerous. Hot metal, confined spaces, fumes, sparks. But they kept working, because every day counted. Inside the ships, different teams tackled different problems. Electrical workers rewired entire sections, hundreds of miles of wire, thousands of connections, all contaminated by seawater, all needing replacement. Machinists disassembled the massive turboelectric power plants. These weren't simple engines. They were complex systems of turbines, generators, motors, and reduction gears. Each component had to be cleaned, inspected, repaired, or replaced. The work required precision. Tolerances measured in thousandths of an inch. Parts that weighed tons but had to fit perfectly. And all of it had to be done quickly. Because while Pearl Harbor repaired ships, Kaiser built them. In Richmond, California, a shipyard that didn't exist in 1940 was about to change naval warfare. Henry Kaiser was not a shipbuilder. He was a construction magnate. Hoover Dam, Grand Coulee Dam, Bonneville Dam. Kaiser built them all ahead of schedule and under budget, but he'd never built a ship. That didn't stop him. In December 1940, Kaiser broke ground on Richmond Shipyard Number One. The site was chosen carefully. Richmond had waterfront access. It was near San Francisco's industrial capacity. It had railroad connections. And, most importantly, it had available land. Kaiser wasn't building one shipyard. He was building 4. Yard 1 started construction in December 1940. Yard 2 followed in January 1941. Yards 3 and 4 came in 1942. Each yard was a city unto itself. Machine shops, fabrication facilities, warehouses, cranes, ways for launching ships, and workers, tens of thousands of them. Kaiser recruited aggressively. Farmers from Oklahoma's Dust Bowl, factory workers from Detroit, housewives from California, anyone willing to learn. Most had never seen a shipyard. That didn't matter to Kaiser. He'd train them. Traditional shipbuilding required years of apprenticeship. You learned from master craftsmen. You started as a helper. You worked your way up. Kaiser didn't have years. He had weeks. So he simplified the work. Instead of teaching workers to build an entire ship, he taught them to build one component. Master one task. Repeat it perfectly. A worker might spend 8 hours a day welding the same joint, the same angle, the same technique, every day, for months. They became incredibly good at that one task. And when thousands of workers each mastered one task, ships appeared. Kaiser divided each Liberty ship into modular sections. The bow section was built in one area of the yard, the stern in another, the midship section in a third. Engine rooms were assembled separately. Superstructures were prefabricated. Each section was built on its own schedule. When complete, it was moved to the final assembly area. Here's where Kaiser's innovation became revolutionary. Instead of building a ship from the keel up, one plate at a time, Kaiser assembled prefabricated sections. Massive cranes lifted bow sections weighing hundreds of tons, positioned them precisely. Welders joined them to midship sections. Stern sections were added. The ship grew from modules, not from scratch. The speed was astonishing. Traditional shipbuilding used rivets. Riveting required skilled workers. Each rivet had to be heated, inserted into pre-drilled holes, hammered into place while hot. It was slow. It was labor-intensive. It required extensive training. Kaiser used welding. Welding was faster. It required less skill for basic joints. It created stronger connections. And it could be taught in 2 weeks. Kaiser's training program was simple. 2 weeks of instruction. Practice on scrap metal. Pass a certification test. Start working. Women learned welding alongside men. In 1942, 30% of Kaiser's workforce was female. They worked the same jobs, the same hours, the same dangerous conditions. Rosie the Riveter became the iconic image. But most of Kaiser's workers were welders, not riveters. The working conditions were brutal. 3 8-hour shifts, round the clock, 7 days a week. Inside a ship under construction, temperatures reached over 100 degrees. Welding created toxic fumes. Sparks flew constantly. Noise was deafening. Workers wore minimal safety equipment by modern standards. Accidents were common. Burns, falls, crushed limbs from moving steel plates. But the pay was good. Better than most workers had ever seen. Better than farming in Oklahoma. Better than factory work in Detroit. Welders earned around $1 per hour. Skilled positions paid more. Overtime was plentiful. For families escaping the Great Depression, it was prosperity. Kaiser built entire cities for his workers. Vanport, near Portland, housed 42,000 people, modular housing, schools, daycare centers, medical facilities. The medical program Kaiser established for workers became Kaiser Permanente. Today, one of America's largest healthcare systems, born from the need to keep shipyard workers healthy. But in 1942, its purpose was simple: get workers back to work as fast as possible, because every minute counted. Kaiser ran his shipyards like assembly lines. He tracked production meticulously. Time studies for each task, efficiency ratings updated monthly, competition between yards. Yard 1 competed with Yard 2. Richmond competed with Portland. Kaiser's yards competed with traditional shipbuilders. The Maritime Commission published efficiency rankings. Kaiser's yards dominated the top positions. Awards were created. The M pennant for high efficiency, Labour Merit Award, pins for workers. Yard managers obsessed over every detail. How many welds per hour? How much steel per worker? How many days from keel laying to launch? Edgar Kaiser managed the Oregon yards. Clay Bedford managed Richmond. They competed ferociously. In August 1942, Oregon broke records. They launched Liberty ship SS Joseph N. Teal in just 10 days. 23 days from keel laying to launch. It was extraordinary, until Richmond beat it. November 8, 1942, Richmond Shipyard No. 2. Keel laid at 12:01 a.m. for SS Robert E. Peary. The entire yard focused on this one ship. Workers from other ships were reassigned, the best welders, the fastest crane operators, the most experienced foremen. Materials were pre-positioned, every plate, every beam, every component ready. The work was choreographed like a ballet. As one section was completed, the next began immediately. No delays, no waiting, no wasted motion. 4 days, 15 hours, 29 minutes after the keel was laid, SS Robert E. Peary slid into the water. The event was partly propaganda. President Roosevelt's daughter Anna christened the ship. Newsreel cameras captured everything. The footage played in theaters across America. But it proved something real. American industrial capacity had no ceiling, only determination. The Peary record was never beaten, not because it was impossible, but because there was no point. Building a ship in 4 days required extraordinary effort. It diverted resources from other ships. It was inefficient, but building a ship in 2 weeks was sustainable. Kaiser could do that every day, 3 ships per week from 7 yards. That's what mattered, not records, but sustained production. By the end of 1942, Kaiser's yards had built over 300 ships. In 1943, they built over 500. In 1944, over 600. Each ship was a 441-foot floating warehouse. Each could carry 9,000 tons, enough cargo to supply an infantry division for a week, enough fuel to keep an armoured division moving for days, enough ammunition to fight a major battle, and if the ship was sunk, another would replace it within 2 weeks. That's what broke Japan's back. Not superior tactics, not better weapons, not American fighting spirit, industrial capacity, the ability to lose ships and replace them faster than Japan could sink them. The numbers became absurd. In 1942, German U-boats sank 1,662 Allied merchant ships. American shipyards built 863, a deficit. But in 1943, production increased. 1,799 ships built. German sinkings declined as anti-submarine warfare improved. By 1944, America built 2,447 merchant ships. The Germans sank fewer than 500, a ratio of 5 to 1. Production outpacing destruction. Japan faced the same mathematics in the Pacific. Submarines sank Japanese merchant ships faster than Japan could replace them. By 1944, Japan's merchant marine was collapsing. Raw materials couldn't reach factories. Food couldn't reach cities. Fuel couldn't reach military bases. American merchant ships, meanwhile, multiplied. Every weapon, every tank, every airplane, every gallon of fuel, every can of food, every bullet, all crossed the Pacific on ships Kaiser built. The Liberty ships weren't perfect. They were built quickly, not elegantly. They used obsolete engines, reciprocating steam engines instead of modern turbines, slower, less efficient, but available. They had structural weaknesses. In cold water, some Liberty ships developed cracks. A few broke in half. Metallurgical problems with the steel. But Kaiser improved. Each ship incorporated lessons from the last. Better welding techniques, improved steel quality, stronger structural bracing. By 1944, Liberty ships were being replaced by Victory ships, faster, more modern, better engineered. Kaiser built those too. 219 Victory ships from his yards. The production never stopped. From December 1940 to September 1945, 57 months, 1,490 ships, one every 38 hours, and every ship represented more than just tonnage. Each one was a message to the Axis. You cannot win a war of attrition against this. Japan learned that lesson the hard way. The first Liberty ship built by traditional methods took 244 days. Kaiser reduced that to 70 days, then 50, then 42. In September 1942, Kaiser's Portland, Oregon yard built the SS Joseph N. Teal in 10 days. That record stood for 2 months. On November 8, 1942, workers at Richmond Shipyard No. 2 laid the keel for the SS Robert E. Peary at 12:01 a.m. They worked in 3 shifts around the clock. 250,000 parts, 14 million pounds of steel, assembled, welded, painted, and launched. 4 days, 15 hours, and 29 minutes later, SS Robert E. Peary slid into the water. Less than 5 days to build a 441-foot cargo ship. The event was partially a publicity stunt. President Roosevelt's daughter Anna christened the vessel. Newsreels played in theaters across America, but it proved something critical. American industrial capacity was limitless. The numbers became staggering. By the end of 1942, Kaiser's 7 shipyards employed 97,000 workers. They built 3 Liberty ships every 2 days. Each ship could carry 9,000 tons of cargo, 2,840 jeeps, 440 tanks, or 230 million rounds of rifle ammunition. The ships were called ugly ducklings by some. They were built with cheap materials, obsolete engines, minimal amenities. They were expected to last 5 years. Many lasted only 1. But that was the point. Each Liberty ship only had to make 1 successful voyage to be considered worth the investment. At an average cost of $2 million, they were expendable, and America built them faster than Germany could sink them. In 1941, German U-boats sank 1,300 Allied merchant vessels. In 1942, 1,662. But American shipyards built 863 new ships in 1942, 1,799 in 1943, 2,447 in 1944. By 1943, America was building merchant ships 3 times faster than they were being sunk. The strategic implications were enormous. Japan had calculated that America's industrial base was 3,000 miles from the Pacific battlefront. Every ship, every tank, every airplane had to cross an ocean. Germany controlled the Atlantic with U-boats. Japan controlled the Pacific with island fortresses. Neither could cut the supply lines, because American industry produced faster than the enemy could destroy, and nowhere was this more evident than in Pearl Harbor. By April 1943, USS West Virginia left Pearl Harbor under her own power. Destination: Puget Sound, Navy Yard for permanent repairs and modernization. The work at Puget Sound took 16 months. Workers didn't just repair West Virginia, they rebuilt her. Her superstructure was completely redesigned. Old cage masts were replaced with modern tripod masts. Her anti-aircraft armament was quadrupled. New radar systems were installed. New fire control computers. New communications equipment. The battleship that emerged in July 1944 looked nothing like the ship sunk in 1941. She was faster, more powerful, more accurate, and she wanted revenge. On October 25, 1944, USS West Virginia participated in the Battle of Surigao Strait, the last battleship versus battleship engagement in naval history. West Virginia's radar-guided fire control system was the most advanced in the world. Her crew detected Japanese battleship Yamashiro at a range of 22,000 yards, more than 12 miles, in total darkness. West Virginia's 16-inch guns opened fire, 16 salvos, 93 rounds of armor-piercing shells. Each round weighed 2,700 pounds. Yamashiro sank in minutes. The battleship that Japan thought they'd destroyed at Pearl Harbor had helped sink one of Japan's own. USS California returned to service in January 1944. She fought at Saipan, Guam, Leyte Gulf, Lingayen Gulf, and Okinawa. USS Nevada returned in October 1942. She bombarded Attu in the Aleutians in May 1943. She supported the D-Day landings at Utah Beach in June 1944. She returned to the Pacific for Iwo Jima and Okinawa. USS Tennessee, USS Maryland, USS Pennsylvania, all returned to service. All fought across the Pacific. Of the 8 battleships at Pearl Harbor on December 7, 1941, only 2 never returned to service. USS Arizona remained where she sank, a permanent memorial. USS Oklahoma was refloated but deemed too damaged for repair. 6 battleships returned to war, each one a floating middle finger to Japanese planning, because Japan had made the same mistake as Germany. They'd underestimated American industrial capacity. Japan's entire industrial output for 1941 was 51 million tons of steel. America produced 75 million tons. Japan built 6 aircraft carriers between 1942 and 1945. America built 151. Japan produced 76,000 aircraft during the entire war. America produced 300,000. The disparity was so vast that American factories built more aircraft in 1 year than Japan built in the entire war. But the most devastating comparison wasn't in new construction. It was in repair. Service Squadron 10 revolutionized naval operations in the Pacific. Before 1943, damaged ships had to return to Pearl Harbor or the West Coast for repairs. That meant weeks out of action, sometimes months. A destroyer damaged off Guadalcanal faced a journey of thousands of miles, back to Pearl Harbor, then to a West Coast shipyard if damage was severe. The round trip took 2 months minimum, often longer. Admiral Chester Nimitz recognized this as a strategic vulnerability. Every ship in transit for repairs was a ship unavailable for combat. The math was brutal. If 10% of the fleet was damaged in any given month and repairs took 2 months, 20% of the fleet was permanently unavailable. Nimitz had a different vision: bring the repair capability to the fleet. In September 1943, he ordered the creation of Service Squadron 10. The concept was revolutionary. Instead of ships going to shipyards, the shipyard would go to the ships. Commodore Worrall Carter took command. His initial request was for 10 ships, floating dry docks, repair ships, tenders, supply vessels. The Navy gave him 13. It wasn't enough. By war's end, Service Squadron 10 would grow to over 300 vessels. The core capability was the floating dry dock. These were massive steel structures, U-shaped platforms that could be partially submerged. A ship would sail into the opening. Pumps would remove water from ballast tanks. The dry dock would rise, lifting the ship completely out of the water. The largest dry docks could accommodate battleships and aircraft carriers, ships displacing 45,000 tons. Lifted out of the water, in the middle of the Pacific Ocean. Once lifted, welders could access the hull. Battle damage below the waterline became accessible. Torpedo holes could be patched, damaged propellers replaced, hull plating repaired. Repair ships complemented the dry docks. These were essentially floating factories, machine shops with lathes and milling machines, foundries that could cast replacement parts, electrical shops with spools of wire and switchgear, carpentry shops, pipe fitting shops, optical shops for repairing fire control instruments. Each repair ship carried tons of spare parts, valves, pumps, electric motors, bearings, pipes, hundreds of different items. And if they didn't have the part needed, they could manufacture it. The machine shops on repair ships were extraordinary. Lathes that could turn shafts 6 inches in diameter, mills that could shape steel plates, welders qualified to work on critical structures. These weren't makeshift facilities. They were professional-grade machine shops, capable of precision work. USS Vulcan was one of the first dedicated repair ships, commissioned in 1941, crew of over 1,200, including machinists, electricians, welders, pipe fitters, and specialists in every trade needed to maintain warships. Vulcan could manufacture a replacement propeller shaft for a destroyer, machine it from bar stock, balance it, install it, a repair that would take weeks at a shipyard. Vulcan could do it in days, at sea. The impact on fleet operations was immediate. In January 1944, Service Squadron 10 established its first forward base at Majuro Atoll in the Marshall Islands. The atoll had been captured specifically for this purpose. Within weeks, the squadron had created a repair facility, floating dry docks anchored in the lagoon, repair ships moored nearby, supply vessels providing materials. USS Franklin was hit by bombs in March 1945. Over 800 men killed. Massive fires throughout the ship. Her flight deck was wrecked. Her hangar bay destroyed. Franklin limped to Ulithi. Service Squadron 10 went to work. They couldn't fully repair the carrier. The damage was too extensive, but they could make her seaworthy. Patch the holes. Restore enough buoyancy to make a 5,000-mile voyage. Franklin sailed to Brooklyn Navy Yard for permanent repairs, but she made it. Because Service Squadron 10 kept her afloat. The squadron's most impressive work came in February 1945. USS Randolph was at Ulithi when a Japanese kamikaze struck her flight deck. The impact tore a massive hole, 60 feet long, 20 feet wide. The wooden flight deck was shattered. Steel structural members bent and twisted. Randolph needed a flight deck to operate aircraft. Without it, she was useless. Traditional repair would require returning to Pearl Harbor, entering Drydock, cutting away damaged structure, fabricating new support beams, installing new flight deck. Months of work. Service Squadron 10 did it in 18 days. They fabricated new structural steel on repair ships, cut replacement flight deck sections from timber stored on supply vessels, lifted the pieces into place with floating cranes, welded the structure, bolted down the deck. Randolph returned to combat operations without leaving Ulithi. This capability changed the strategic calculus of the Pacific War. Ships could stay forward, engaged in continuous operations, knowing that if they were damaged, repair was available locally. This enabled the fast carrier task forces to maintain pressure on Japan. Instead of rotating carriers back to Pearl Harbor for maintenance, they rotated to Ulithi. Service Squadron 10 handled the work. The tempo of operations increased dramatically. In 1942, major fleet operations were months apart. The carriers needed time between engagements, for repairs, for maintenance, for crew rest. By 1944, operations were continuous. Fast Carrier Task Force 58 struck Japanese positions repeatedly. Palau in March. Truk in April. The Marianas in June. The Philippines in October. Between operations, they retreated to Ulithi. Service Squadron 10 repaired battle damage, restocked ammunition, refueled ships, replaced worn equipment, and within days the fleet was ready again. Japan couldn't match this. When a Japanese carrier was damaged, it had to return to Japan, thread through submarine-infested waters, hope to make it. If it survived the journey, it waited for dry dock space. Japan had limited facilities. Ships queued for repairs. Carrier Zuikaku was damaged in June 1944 at the Battle of the Philippine Sea. She made it back to Japan, entered dry dock in August. Repairs took 2 months. She returned to service in October, just in time to be sunk at Leyte Gulf. 4 months from damage to destruction. With 2 months out of action for repairs, American carriers damaged in the same battle were repaired at Ulithi, back in action within weeks. The difference was Service Squadron 10, and it wasn't just carriers. USS Birmingham was damaged by a kamikaze in October 1944. Her superstructure was wrecked, her fire control systems destroyed, over 200 men killed. Service Squadron 10 repaired her, replaced damaged equipment, fabricated new structural steel, rewired electrical systems. Birmingham returned to combat in November, less than a month after being hit. USS Houston was torpedoed off Formosa in October 1944. The torpedo hit her engineering spaces, blew a 40-foot hole in her hull, flooded multiple compartments. She lost all power, all propulsion. She was dead in the water. tugs towed Houston over 1,000 miles to Ulithi. Service Squadron 10 patched the hole, restored partial power, made her seaworthy. Houston sailed to the United States for permanent repairs. But she survived because Service Squadron 10 saved her. The squadron's work extended beyond battle damage. Warships operating continuously developed mechanical problems. Bearings wore out. Boilers needed maintenance. Electrical systems failed. Service Squadron 10 handled routine maintenance. Destroyers could pull into Ulithi for a week, receive an overhaul, return to duty. This kept the fleet operational. The statistics were staggering. In February 1945 alone, Service Squadron 10 worked on 52 vessels, battleships, carriers, cruisers, destroyers. Some received battle damage repairs. Others underwent routine maintenance. A few needed complete rebuilds of damaged systems. All were completed. None had to return to Pearl Harbor. The squadron's mobility was equally important. As American forces advanced across the Pacific, Service Squadron 10 moved with them. Majuro in early 1944, Eniwetok by May, Manus in the Admiralty Islands by September, Ulithi by October. Each move brought repair capability closer to the combat zone, reduced transit time for damaged ships, increased fleet availability. The Japanese watched this with growing desperation. They couldn't replicate it. They lacked the industrial capacity to build floating dry docks. They lacked repair ships with machine shops. They lacked the skilled workforce to operate them. They lacked the supply network to stock them with parts. Most critically, they lacked the strategic vision. Japanese naval doctrine focused on decisive battle, concentrate forces, seek engagement, destroy the enemy fleet in one climactic action. American doctrine focused on sustained operations, continuous pressure, relentless advance, wear down the enemy over time. Service Squadron 10 enabled the American approach by keeping ships in the fight, by repairing damage quickly, by maintaining the fleet forward. It was unglamorous work. No Medal of Honor for welding a patch, no headlines for machining a propeller shaft, no glory for changing a destroyer's boilers. But it won the war. Because wars aren't won by dramatic battles. They're won by logistics, by the ability to sustain combat operations, by keeping equipment functional. Service Squadron 10 kept the Pacific Fleet functional, and in doing so, they broke Japan's will to continue. Every time a Japanese commander saw American ships return to battle, ships that should have been sunk or in dry dock for months, it reinforced a terrible truth. America could not be defeated by attrition. They repaired faster than Japan could inflict damage. They built faster than Japan could sink ships. They sustained operations longer than Japan could match. The war became a race Japan couldn't win. By 1945, the combined fleet had effectively ceased operations, not because every ship was sunk, but because damaged ships couldn't be repaired fast enough, because fuel was scarce, because spare parts were unavailable, because the industrial base supporting the fleet had collapsed. Meanwhile, the U.S. Pacific Fleet grew stronger each month. New construction, repaired vessels, modernized ships, all supported by Service Squadron 10, all kept in action by repair ships and floating dry docks, all sustained by an industrial capacity that seemed infinite, the battle of industry, won before the shooting stopped, by welders working in floating dry docks, by machinists turning replacement shafts, by electricians rewiring damaged systems, by workers who never fired a shot but kept the weapons firing. When a Japanese ship was damaged, it had to return to Japan for repair. That meant a journey of thousands of miles through submarine-infested waters. Many damaged ships were sunk before reaching port. Those that made it waited for repairs. Japan had limited dry dock capacity, limited skilled workers, limited materials. A ship damaged in 1943 might not return to service until 1945. American ships were back in action in weeks. This created a strategic death spiral for Japan. Each battle inflicted casualties on both sides, but American ships returned to service quickly. Japanese ships didn't. The effective fleet size diverged rapidly. After the Battle of the Philippine Sea in June 1944, Japan lost 3 carriers and over 600 aircraft. American losses were minimal, but even where losses were equal, America recovered faster. USS Franklin was hit by 2 bombs in March 1945. The bombs penetrated her flight deck and detonated inside the hangar. Fully fueled aircraft exploded. Fires raged out of control. Over 800 men died. Franklin should have sunk, but her crew fought for hours. They contained the fires. They saved the ship. Service Squadron 10 patched her up enough to make a 5,000-mile journey back to New York. Franklin was repaired and would have returned to service if the war had continued. Japan had no equivalent capability. When carrier Taiho was torpedoed in June 1944, poor damage control led to fuel vapor explosions. She sank with over 1,600 men, a ship that might have been saved with proper damage control and repair facilities. This pattern repeated across the Pacific. American destroyers lost their bows to torpedoes and had new bows welded on at forward bases. Japanese destroyers with similar damage sank because there was no one to save them. American submarines damaged by depth charges received repairs at forward tenders. Japanese submarines with similar damage struggled back to Japan. The cumulative effect was devastating. By 1945, the Japanese combined fleet had effectively ceased to exist, not because every ship had been sunk, but because damaged ships couldn't be repaired fast enough to return to action. America's fleet grew larger every month, new construction plus repaired vessels. Japan's fleet shrank. Losses exceeded repairs and new construction. The mathematics of attrition were brutal, and it all traced back to December 7th, 1941, to Captain Homer Wallin standing at the edge of a dry dock making calculations, to Henry Kaiser building ships in less than a week, to thousands of welders, electricians, machinists, and engineers who worked around the clock. They proved something the Axis powers never understood. Industrial capacity wasn't about factories. It was about will. The will to work 18-hour shifts, the will to learn new skills, the will to innovate under pressure, the will to repair what seemed irreparable. USS West Virginia sat on the bottom of Pearl Harbor for 6 months. 30 months later, she was bombarding Japanese positions at Leyte Gulf. That transformation required over 1 million man-hours of labor. It required 90,000 tons of steel. It required replacing her entire electrical system, rebuilding her engines from the turbines up, fabricating new armor plates, rewiring every circuit, repairing every damaged compartment, and Pearl Harbor Navy Yard did it while simultaneously repairing 5 other battleships, dozens of cruisers and destroyers, and maintaining the rest of the Pacific Fleet. The Japanese had calculated that such repairs were impossible. They were correct by pre-war standards, but they hadn't accounted for American adaptability. Wallin's salvage teams developed techniques that didn't exist in any engineering manual. They invented new pumping systems. They pioneered underwater welding methods. They created wooden and steel patches that could seal holes no one thought could be sealed. Kaiser's shipyards revolutionized manufacturing. Prefabrication became standard. Welding replaced riveting. Assembly line techniques came to shipbuilding. The innovations developed in World War II became the foundation for post-war industry. Kaiser Permanente, the healthcare system, grew from medical services Kaiser provided to shipyard workers. The management techniques developed to coordinate massive industrial projects became business school case studies. But in 1945, those innovations had one purpose: win the war, by producing faster than the enemy could destroy, by repairing faster than the enemy could inflict damage, by turning industrial capacity into strategic advantage. On September 2, 1945, representatives of the Japanese Empire boarded USS Missouri in Tokyo Bay. They signed instruments of surrender. Among the hundreds of American warships present was USS West Virginia, flying the same flag she'd flown on December 7, 1941, the flag that had been raised that Sunday morning, the flag that had been carefully preserved while the ship sat on the harbour bottom, the flag that returned to sea when West Virginia was resurrected. That flag flew in Tokyo Bay as a symbol, not just of military victory, but of industrial triumph. The ship that Japan thought they'd destroyed witnessed their surrender, and she was one of thousands. America built 50 Essex-class aircraft carriers during the war. Japan built 3 large carriers. America built 275 destroyers. Japan built 63. America produced 400,000 artillery pieces. Japan produced 30,000. The disparity wasn't because American factories were bigger. It was because American industry was integrated, innovative, and incredibly fast. When Liberty ships were sinking faster than they were being built in early 1942, Kaiser redesigned the production process. Within 6 months, production exceeded losses. By 1943, production was triple the loss rate. When the Navy needed more carriers, Kaiser converted his shipyards to carrier production. Casablanca-class escort carriers rolled out every week, 50 of them in 2 years. When Service Squadron 10 needed more floating dry docks, factories built them. Massive steel structures that could lift a battleship, towed across the Pacific, anchored at forward positions. The speed of adaptation was the secret weapon. Japan's industrial base was fixed. Factories in Japan, raw materials from conquered territories, supply lines vulnerable to submarine attack. America's industrial base was flexible. Factories could retool in weeks. Raw materials came from a continent protected by 2 oceans. Supply lines multiplied faster than they could be cut, and when ships were damaged, America repaired them. Fast. The battle-damaged destroyer USS Selfridge lost her bow to a torpedo in October 1943. Service Squadron 10 fabricated a temporary bow. Selfridge sailed to Mare Island Navy Yard, received a permanent bow, returned to combat in May 1944. 7 months from catastrophic damage to full combat readiness. Japan couldn't match that pace. Carrier Shokaku was torpedoed in June 1944. She sank. No time for damage control. No floating dry docks nearby. No repair squadron to save her. The strategic implication was clear. America could trade ships with Japan and win through sheer industrial output. Japan had to achieve perfect victories to avoid losing the war of attrition. There are no perfect victories in war. So Japan lost. Ship by ship. Battle by battle. Month by month. While America's fleet grew stronger, because farmers from Oklahoma learned to weld in 2 weeks and built Liberty ships. But because housewives from California operated cranes that lifted 10-ton armor plates, because engineers from MIT calculated the stress tolerances on patched torpedo holes, because shipyard workers in Pearl Harbor turned wrecks into warships. The Battle of Industry was won in Richmond, California, in Puget Sound, Washington, in Pearl Harbor, Hawaii, in dry docks and shipyards and floating repair facilities across the Pacific, by people who refused to accept that damage was permanent. that losses were final, that industrial limits were fixed. They looked at capsized battleships and saw a challenge, not a defeat. They looked at ships sinking faster than they could be built and innovated until the balance shifted. They proved that wars aren't won by the strongest. They're won by those who can sustain the fight. And America sustained it by repairing faster than the enemy could damage, building faster than the enemy could sink, adapting faster than the enemy could react. That was the real lesson of World War II in the Pacific. Not Midway's tactical brilliance, not Iwo Jima's courage, not Hiroshima's devastating power, but Richmond shipyard building a vessel every 4 days, Pearl Harbor raising 6 battleships from the bottom, Service Squadron 10 welding new flight decks while under fire, the unglamorous work of industry, the unsung heroism of welders, the quiet revolution of mass production. That's what defeated Japan. Not carriers, but the capacity to build more carriers than the enemy could sink, not battleships, but the ability to repair them faster than the enemy could damage them. The war of industry. Won before the shooting stopped, by men and women who never fired a shot, but built the weapons that won every battle. USS West Virginia in Tokyo Bay, repaired, rebuilt, victorious, a testament to the simple truth that broke an empire. You can't win a war of attrition against an enemy who repairs faster than you can damage them. Japan learned that lesson at a cost of 6 million dead and an empire in ashes. America proved it with welding torches, floating dry docks, and the relentless productivity of a nation that refused to quit.